Diving deep into scikit-learn's VotingRegressor, a comprehensive guide. The VotingRegressor in scikit-learn is a powerful ensemble method that combines the predictions of multiple individual regression models. It offers a simple yet effective way to leverage the strengths of different models and improve overall prediction accuracy and robustness. Let's break down the core features and functionalities of VotingRegressor, exploring its inner workings and practical applications. 1. The essence of ensemble methods. Ensemble methods, like VotingRegressor, are a fundamental concept in machine learning that centers around the idea of combining multiple models to achieve a more accurate and reliable prediction. By harnessing the collective wisdom of diverse models, ensembles can often outperform individual models, especially in scenarios with complex data and high variability. Key advantages of ensemble methods: reduced variance by averaging predictions across multiple models. Ensembles mitigate the impact of individual model biases and noise, leading to more stable and reliable predictions. Improved accuracy. Ensembles often achieve higher predictive accuracy than individual models due to their ability to learn different aspects of the data. Increased robustness. Ensembles are less prone to overfitting, as they are less sensitive to individual model errors. 2. The mechanics of VotingRegressor. The VotingRegressor operates on a simple principle. Multiple models. It takes as input a collection of individual regression models, each trained on the same dataset. Prediction aggregation. When making a prediction, each model provides its own output, and these individual predictions are then combined according to a predefined voting strategy. Voting strategies. The VotingRegressor offers two voting strategies. Hard voting. The final prediction is determined by the majority vote among the individual models. This approach assumes that models with strong individual performance are more likely to provide correct prediction. Soft voting. The final prediction is computed as a weighted average of the individual model predictions, where weights are determined by the individual model's performance. This approach allows models with weaker individual performance to still contribute to the final prediction. Choosing the right voting strategy. The choice between hard and soft voting depends on the specific application and the characteristics of the individual models. Hard voting is suitable when individual models are highly accurate and reliable, as it gives more weight to the models with the highest individual accuracy. Soft voting is more robust to outliers and allows for a more nuanced combination of predictions. Even if some models perform poorly, it's particularly useful when individual models are diverse in their prediction styles. 3. Building and training a VotingRegressor. Creating and training a VotingRegressor is straightforward. Here's a basic example. Python. From sklearn, linear model import linear regression. From sklearn, ensemble import random forest regressor. From sklearn, ensemble import VotingRegressor. From sklearn, model selection import train test split. From sklearn, datasets import load Boston. Load the Boston housing dataset. Boston load Boston. X Boston. Data. Y Boston. Target. Split the data into training and testing sets. X train. X test. Y train. Y test train test split X. Y. Test size 0.2. Random state 42. Define the individual models. Model 1 linear regression. Model 2 random forest regressor random state 42. Create the VotingRegressor with hard voting. VotingRegressor estimators. LR. Model 1. RF. Model 2. Train the ensemble. VotingRegressor. Fit X train. Y train. Make predictions on the test set. YPRED VotingRegressor. Predict test. Evaluate the model performance. Use metrics like mean squared error, R-squared, etc. Key points. Estimators. The estimator's argument takes a list of tuples, where each tuple contains a name for the model and the model itself. This enables you to give meaningful labels to your individual models. Voting. The voting argument specifies the voting strategy, either hard or soft. Weights. If using soft voting, the weights argument allows you to specify custom weights for each model. Training. The fit method trains all the individual models on the training data. 4. Evaluating the performance of a voting regressor. Evaluating the performance of a voting regressor is similar to evaluating any other regression model. You can use standard metrics like mean squared error. MSE measures the average squared difference between predicted and actual values. Root mean squared error. RMSE the square root of MSE, providing a more interpretable error measure in the original units. R squared represents the proportion of variance in the dependent variable explained by the model. 5. Advantages and considerations of voting regressor. Advantages. Simplicity. The voting regressor provides a straightforward way to combine multiple models without complex hyperparameter tuning. Improved generalization by combining predictions from diverse models. Ensembles are less prone to overfitting and generalize better to unseen data. Robustness. Ensembles are less affected by outliers and noisy data compared to individual models. Considerations. Computational cost. Training multiple models can increase the computational burden, especially when dealing with large datasets. Model selection. Choosing the right individual models and ensuring their diversity is crucial for effective ensemble performance. Interpretability. Understanding the contribution of individual models to the final prediction can be challenging, especially with complex ensembles. 6. Real-world applications. Voting regressor finds applications in various domains, including financial forecasting, predicting stock prices or market trends by combining predictions from different forecasting models. Healthcare, predicting patient outcomes or disease progression using multiple diagnostic and prognostic models. Customer analytics, improving customer churn prediction by combining models based on different customer behavior patterns. Conclusion. Voting regressor is a powerful and versatile tool for building robust and accurate regression models. By combining the strengths of multiple individual models, it can significantly enhance prediction accuracy, reduce variance, and increase robustness. Understanding the principles behind ensemble methods and the specific functionalities of voting regressor allows you to effectively leverage this valuable tool in your machine learning projects, leading to more insightful and reliable predictions.